So last session, we stopped here with subword regularization, and in particular, the Unigram language model when it comes to giving us subword candidates. And the cool thing about the Unigram language model method of generating subword candidates, it's going to give us multiple subword segmentations. And why is this useful? Because when you're doing training, every single sentence which is human readable is gonna have multiple versions. For instance, hello world could end up having multiple versions. And this way you are doing data augmentation. Now we know that neural networks like more data, and this is the way that you're increasing the size of data on the fly. And that's why it is gonna act as sort of a regularizer. And the way that you're gonna sample it, you're gonna sample the top 64 ones. This probability, you can keep sampling from it infinitely many samples, but some of them are going to have the highest probability, and those are the ones that you're going to actually use when you're doing your inference. And the idea of Unigram language model was you're going to look at a sequence of tokens. You can represent it based on the independence assumption that each word is going to appear independently in this sentence, which is not a good assumption. That's why later on we are going to do better language models. But this simple language model is actually enough to give us the tokenization process. You are going to write a likelihood. That likelihood is going to be based on these Unigram probabilities. And we wanted to do maximum likelihood estimation. And what are you optimizing over? You're optimizing over these probabilities, over these estimates, for the likelihood of, or the probability of this word appearing in a sentence. So these are the things that you're going to be maximizing over, but there is a catch. To be able to sample this set S, you need to know your probability. To be able to write down this likelihood, you need to do a summation over those probabilities. So it's sort of a chicken and egg problem. To be able to write this summation, you need to know your S, and to know your S, you need to know your probability. And that's why you're going to use an EM algorithm. And it's basically assume you know your probability, sample your S, form your summation, and that's called the expectation part of EM algorithm. And then once you know the summation, you can actually do your maximization step. And the other problem is this summation showing up inside a log. Usually when things happen, that your objective function is of this form, there is a summation within a log, and at the same time, what you are summing over depends on the actual parameters that you want to estimate. Usually a good algorithm is EM algorithm to optimize that. And I guess once you know your probabilities, once you know your likelihood, you can start removing subwords from a seed vocabulary corpus generated from your corpus. You can start removing and then sort them according how much do you lose in terms of your likelihood if you remove that subword. And then you want to remove the subwords that are the least important. So the ones that are gonna minimize your loss, minimize the loss of the information or the loss of your likelihood. And then per each iteration, you're gonna keep the top 80 most important subwords in your dictionary, and you discard the rest of them, the rest of the 20%. Any questions about Unigram language model? Okay, perfect. Now you can go backward. You can go to sentence piece. You had two options. One of them was this Unigram language model. When you're actually doing your training, you can actually specify, do you want to use Unigram language model or do you want to use byte pair encoding? And the sentence piece is going to give you your tokenization, which you're going to use to tokenize your text for translation. Or you can use it to do language modeling later on. So last session, we also covered attention. Any questions about attention mechanism and the transformer architecture? Okay, perfect.